We're going to get started into here in this section is functions. Really, that's what most of this little chapter is about. They're functions. Now, functions kind of mean like graphs and equations and relations. Now, we saw relations before. A relation was where, hang on, a relation is a connection between two different quantities, between two quantities. So in other words, two things. Maybe it's like your height versus your age. Those are two different things. Your height depends upon your age, right? But in this one, we're going to be talking about functions. A function is a special kind of relation. Now you have lots of different relations, right? You have different relations like your brother, your sister, your mom, your dad. But a function is going to be a special kind of one. A function, by definition, is a relation where every x value, hang on, can I do value? Value, oh that's terrible, has exactly, well, I shouldn't say exactly. Let's clean this up. Every x value has only one possible y value. What? So in other words, if you're going to plug in an x value, you're only going to get one answer, period. Yeah, that really means there is only going to be one possible, not more than one. So not more. Okay, so all functions are relations, but not all relations are functions. Think of it as like a thumb, right? You have a whole bunch of fingers. Oh, that's a great hand, isn't it? But you have one thumb. Now, a thumb is a finger, but fingers are not thumbs, okay? So it's a special one. Special. So that's what a function is. A function is a special kind of relation, okay? All functions are relations, but not all relations are functions. Okay. Another way of looking at it is think of a function as a machine, okay? So for any x value that's going to be inputted, right, because you plug in an x value, there's exactly one y value, only one, outputted. Huh? What do you mean outputted? So in other words, here's what I just made this one up. Function. This is a line. We know it's y is equal to 3x minus 2. Okay, we know it's a line, and we know it's going to be starting at minus 2, and it's got a slope of 3, whatever. But this is my function. So any x value that I decide to put in, I'm going to get an output value. So let's say we plug in the x value of, I don't know, let's say 10. If I plug in 10, what am I going to get coming out of here? Well, you take the 10, you plug it into there. 3 times 10 is 30. 30 minus 2 is 28. So the output value would be 28. When the x value is 10, the output value is 28. Now, I just made up 10. It doesn't have to be 10. It could be anything else you want, right? What if it's a negative 1? If I plug in negative 1, I'm going to get 3 times negative 1, which is negative 3. So minus 3 and then subtract off another 2 would be minus 5. Now, if you were to graph this line, this function, x and y, these would be x and y points, right? But so for any x value inputted, I get only one y value. So that's the only, I don't get like negative 5 or negative 18. No, 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 no. There's not two different y values output. There's always one, only one. So this kind of just means, well, it's an equation, right? Anytime you plug in a value, you're only going to get one answer. Okay, that makes sense. So instead of writing y is equal to, right, quite often we'll see this. And it's f bracket x. And it's called function of x. Or sometimes we read it as f of x. F of x. Or sometimes we would say function of x. That's really what it means. Function of x. Doesn't mean f times x. No, 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 no. It just means, in brackets, it means it's a function of x. Now, all of our equations so far, we usually try and deal with x. That's why, right? But because these things are called functions of x. So y is equal to 3x minus 2. There it is, right? Instead of writing it as y is equal to, I could have said function of x is equal to 3x minus 2. So see, the y value is the exact same as f. It means the same thing. The exact same thing. Same. Yeah, so whenever you see f of x, if you wanted to, what some people do is they just immediately change that into y, because that's all it means. It means the y value, okay? Okay, let's get rid of that. Boop. So this can be useful in function notation. Tomorrow we're going to, well, not tomorrow. Next week, we'll look at function notation a little bit. So let's say I had 3x minus 2. There's my function, right? The function of x is 3x minus 2. F of 5 just means plug in 5. 15 minus 2, 13. Done. That's it. So this is just, instead of saying, what is the y value when the x value is this, it's just a shortcut. What about this? F of 10. Remember? When we plugged in 10, oh yeah, I've erased it already, but when we went back and we plugged in 10, that means the x value is 10. So I'm going to take x and plug it into, there. 3 times 10, 30. 30 minus 2, which is 28. So this is like saying the y value equals 28 when the x value is 10. Or let's say f of 0. What? You can plug in anything you want. In fact, it doesn't even have to be a number. What? You could be f of heart. What? Oh, it's a terrible heart. Just means take heart and plug it in for the x. This means 3 hearts minus 2. A little bit more on that tomorrow, but all this really means is if the x value is a heart, it could be anything you want. Plug in whatever. Okay, so we're just going to stick to numbers for now. So considering that a function can only have, or a function can have only have one y value for the x. One y value. Only one. Okay, let's compare the difference. What do you mean? Well, here's a function over here, right? This is an x and y relationship. When the x value is this, the y value is that. Okay, so if the x value is 3, do I get one y value? Yes, only one. X value is 8. I only get one y value. And the x value, this is a function. Hang on, both of these go to 4, but that's okay. When the x value is 10, I only get one y value. This one is a function. Well, I shouldn't do that. I should use the word function. So this one is a function. This one's not. Why not? Not a function. Here's why. When the x value is 3, I get one y value. Yeah, sure. When the x value is 8, I get 13, but I also get 6, right? So when the x value is 8, I could get two different values. I could get either 13 or I could get 6. This is two different y values. And this one, it shouldn't say f. This should actually say y. This one should really say f. Now, we use f of x and y back and forth. They're the same kind of thing. But this thing is not a function because I have two y values, right? Think of it. When the x value, what's f of 8? F of 8 means when the x value is 8, well, let's see, I could get 13 or 6. 13 or 6. Okay, so that means it's not a function. This thing is not a function. So anytime you see an x value giving you more than one y value, that just means it's not a function. Okay, so if it's an equation like this, y is equal to, if you can isolate y, and we did, right? We've got it all here. You can say f of x, that's what y is. So the function of x is 5x squared minus 20. That's a function. Anytime you can isolate y, get it all by itself, it's a function. So pretty much all of our equations that we've seen so far are functions. This one, by the way, is not a function. Here's why. This thing's not just x and y, it's got x squared. This one had an x squared, but that's okay. Look, if I was to isolate y here, if I was to move the x over, y squared is equal to 25 minus x squared. Okay, and then if I want to get rid of the square, I'd have to do the square root. So here's the thing. When you do the square root of some big ugly beast, whatever this thing is, it could have been plus or minus. What? Think about it. Think about this. What if y squared is equal to 100? Y could equal 10 or negative 10. So plus or minus 10, they both work. So whenever you have a y squared, if you have to do a square root, you're going to get plus or minus, right? A plus or a minus. 25 minus whatever this thing is. So this is two different functions. See, one's a plus, one's a minus. It's two values. So for that reason, anytime you see a y squared, it's never a function. Not a function. This one is a function, this one's not. So anytime you see a y squared, guaranteed, that's the dead giveaway. It's not a function. Okay, on a graph. What? This is a weird kind of sideways curve. This is a relation. It's a relation between x and y, but it's not a function. Here's why. How about this? When the x value is, I don't know, let's say when the x value is 2, what's the y value? Well, it could be 1. Or it could also be 1, 2, 3, 4. It could be 5. Oh, I see. See that? When the x value is 2, the y value could be 5 or 1. Or when the x value is negative 1, for example, here's two different y values, there and there. So in other words, if you can draw a vertical line, okay, that's not a vertical line, and it hits it twice, then it's not a function. Not a function. So anywhere you can draw a vertical line, if I can draw a vertical line anywhere, boom. As soon as it hits it twice, it means it's not a function. What about horizontal? We don't care about horizontal. That's okay. Let's think about it here. This thing is kind of weird. It's a diagonal line, and then it stops and it jumps over to this dot here, and then it's got a curve. Okay, so this is some kind of weird graph. I don't know what the equation is. I also don't care. But think about it. Anywhere I draw a vertical line, it only hits once, 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 once. There it doesn't hit at all. Only hits once, once, once. Anywhere you draw a vertical line, it's always, yes, this one is a function. Okay, so those are actually two different things that we actually, well, this one's called the vertical line test for graphs. So if you're looking at a graph, so if you can draw a vertical line, it's got to be vertical, not horizontal, line that intersects twice or more, right? 2 or more times, that means it's not a function. So this one is not a function because I can draw a vertical line. Now, if I draw a vertical line here, it only hits once, but that's okay. This thing's not a function. As soon as you can do it once, it's not a function. So that's called the vertical line test. So just think about drawing vertical lines anywhere. It just doesn't have to be huge, just a little vertical line. If it only hits once, that's a function. And the equation test, that's up here. If you can actually solve for y equals, or f equals, that means it's a function. As soon as there's a y squared, not a function. So if you can isolate y equals, or in other words, f of x, right, same thing, f of x equals, then it's a function. And yeah, here's our dead giveaway. The biggest ones, anytime you see a y squared, not going to be a function. Not a function. We will see y squareds later on in other courses when we start graphing curves, and then we'll actually get into circles. For example, a circle, a perfect circle, is this. That's what this thing is. X squared and y squared is equal to 25. That means the radius is 5. We're going to get into those next year. But if you were to actually look at the graph of that, right? If you got a circle, circles are not functions because you can draw a vertical line, boom, or something close to a vertical line, and it hits it twice, means it's not a function. No, not a function. Okay, so these are the ones to start with, and next week we're going to finish up with something called function notation, so plugging in numbers. Okay, that's it for now.